If you look around at the world right now, like in mid-2026, there's this really strange, almost unsettling paradox in how we live.
Yeah. Oh, yeah.
Because, we have this incredibly advanced technology just literally at our fingertips. I mean, we've got AI optimizing our power grids. We have genomic sequencing that reads like the entire code of life in a matter of hours.
Right. It's incredible.
And we have this totally interconnected global economy. You can wake up in Buenos Aires and go to sleep in Geneva. It really feels like we are just the undisputed masters of our environment.
It does feel that way on the surface, yeah.
But then beneath all that gleaming infrastructure, the global health landscape it's precariously fragile. We're constantly navigating this invisible shifting threat matrix.
It's the defining tension of our era, really.
Exactly. We aren't just dealing with localized problems anymore. We are tracking these microscopic entities that cross oceans and infiltrate transit hubs before we even know their names.
Because our modern infrastructure, the very things that make our world so advanced, like international aviation and these massive commercial supply chains,
Right.
those are the exact mechanisms that these microscopic threats exploit. I mean, we have essentially built the perfect delivery system for pathogens.
We really have. Which brings us to the core document that you and I are digging into today. For you listening, we know you want to understand the actual mechanics of what is happening out there, but, minus the apocalyptic doom scrolling and the dense medical jargon.
Yeah, nobody needs more doom scrolling.
Definitely not. So we've been poring over this exhaustive mid-2026 epidemiological report. It's called Viral Outbreaks Containment Status. And our mission for this deep dive into the source material isn't to scare you.
No, not at all.
It's to extract a masterclass. This report is basically a masterclass in how humanity actively tries to track, fight, and, occasionally fails to contain these invisible threats in real time.
And the sheer scope of this document is what makes it so valuable. It maps out 4 highly distinct viral profiles that are, currently playing out across the globe right now.
It covers so much ground.
It does. We're going to look at a fully contained, incredibly high-stakes maritime outbreak involving the Andes hantavirus on a cruise ship.
Which is just a wild story.
Oh, it really is.
Yeah.
They will examine a partially contained, seasonally shifting threat in South Asia driven by the Nipah virus. From there, we move to the heavily managed, sort of endemic baseline of COVID-19.
Right, the embers of it.
Exactly, which requires an entirely different type of global governance.
Yeah.
And finally, we have to look at the worst-case scenario, which is an uncontained, raging epidemic in a highly complex conflict zone.
The Ebola situation.
Yes, fueled by the Bundibugyo strain, happening exactly where our medical tools are lacking the most.
So we're looking at 4 completely different battlefields, essentially, playing by entirely different rules. And reading through this data, I mean, the statistics are dense.
Very dense.
But I want to know the mechanics behind these events. Like, how does a localized incident suddenly require a multi-nation medical evacuation?
Right.
Or why do our incredibly advanced testing systems completely miss certain strains? We really need to look at the architecture of global biosecurity here, because a failure in one of these scenarios is a warning light for the entire system.
It's all connected.
So let's start with the first scenario, which, this genuinely reads like the setup for a locked room mystery novel.
It really does.
I want you listening to imagine boarding a luxury wildlife expedition vessel. You're heading out to the remote corners of the world, and you are totally unaware of the invisible passenger that just boarded with you. We're talking about the MV Hondius.
The incident aboard the MV Hondius is going to be studied in epidemiology classes for decades. This is a Dutch-flagged wildlife exhibition vessel.
Okay.
And to understand the gravity of the situation, you have to look at the inception point. It departed Ushuaia, Argentina on April 1st, 2026.
Right at the tip of South America.
Yeah. Exactly. On board were 147 people. That's 88 passengers and 59 crew members. And this was a highly international manifest. I mean, they had 23 different nationalities on board.
Wow.
And their itinerary was taking them across the South Atlantic Ocean to incredibly remote locations. Mainland Antarctica, South Georgia Island, Tristan da Cunha, St. Helena, and Ascension Island.
I mean, you literally cannot get more isolated than that route. You're in the middle of nowhere.
Nowhere.
But a threat wasn't waiting for them in Antarctica. It was already on the ship on day 1, carried by the index case, right? The first person to introduce the infection.
Right. The index case was an adult male passenger. He boards the vessel on April 1st. But his timeline before the cruise is the critical factor here.
Okay, what was he doing?
He had spent the previous 3 months traveling extensively overland through Argentina, Chile, and Uruguay.
Oh, gotcha.
And then 5 days into the maritime voyage, around April 6, he starts showing symptoms.
What kind of symptoms?
A fever, a persistent headache, some mild diarrhea.
I mean, that could be anything.
Exactly. These are incredibly non-specific symptoms. On a ship, you might assume it's norovirus or just a routine flu.
Sure.
But his condition deteriorates rapidly, and by April 11, he dies on board the vessel.
God, that's awful. And at that moment, nobody has any idea what killed him, right? I mean, the ship doesn't have a high-level microbiology lab to run complex pathogen panels.
No, of course not. It's only later, through retrospective epidemiological investigation, that they figure out he was a probable case of Andes hantavirus.
Right.
The investigators basically trace his movements backward and conclude he acquired the infection before he ever stepped onto the gangway.
So he brought it with him.
Yes, he had environmental exposure to infected rodent droppings somewhere during his travels in South America.
Okay, hold on. I need to stop you there because that transmission model is exactly what I always understood about hantavirus.
Yeah.
Like in North America, we hear about the sin nombre strain, right?
Yes, the sin nombre virus.
And the golden rule with sin number is that it's strictly an environmental hazard. Like you sweep out the old woodshed, you breathe in the contaminated dust from the mouse droppings, and you get incredibly sick.
That's the classic pathway, yeah.
But you don't go home and infect your spouse. You don't infect the nurse treating you. It stops with you. So how is a virus that relies on mouse droppings causing a multi-nation crisis from a steel ship in the middle of the ocean?
You've hit on the exact reason this specific outbreak triggered international panic.
Okay.
You were absolutely right about the sin number strain and indeed almost every other hantavirus in the world. They are what we call dead-end infections for humans.
Right, doesn't spread person to person.
Exactly. But the Andes strain is a profound biological anomaly. It completely breaks the fundamental rules of its viral family.
How so?
The Andes orthohantavirus is the only member of its entire viral genus with a proven, documented capacity for human-to-human transmission.
Wait, really? So it actually mutates or behaves differently inside the human body compared to all the other strains?
Well, the underlying virological mechanisms are still a subject of intense research, but we know it involves how the virus replicates and sheds within the human respiratory tract.
Okay.
With the Andes strain, a highly symptomatic patient who is coughing or even just exchanging bodily fluids can shed enough viable viral particles to infect someone else.
That is terrifying.
It requires close, prolonged contact. You won't catch it passing someone in a grocery store aisle. But if you are sharing a cramped cabin on a ship,
Oh,
or if
no.
you're a doctor examining a patient without high-level personal protective equipment, you are directly in the line of fire.
Right.
And the MV Hondius, being a closed, climate-controlled maritime environment, it acted as the ultimate incubator for this specific rule-breaking pathogen.
Okay, let's trace how this actually cascaded, because reading the chronological timeline of this spread in the report is just dizzying.
It moves fast.
So the index case dies on April 11. But instead of staying contained to that one tragic event, the infection splinters outward geographically. You have case 2, who is an adult female who was a close contact of the index case. She boarded with him.
Right.
And by the time the ship reaches St. Helena on April 24, she is suffering from severe gastrointestinal symptoms.
And she disembarks in St. Helena, which, has very limited medical infrastructure.
Obviously.
So they immediately arrange a medical flight to South Africa. She dies in a Johannesburg clinic on April 26. But the critical piece of the timeline here is that her infection isn't officially confirmed as the Andes virus until May 4.
Wait, meaning for more than a week, a highly lethal human-to-human transmissible virus has crossed an ocean, landed in a major African medical center, and nobody definitively knows what they're dealing with.
Exactly. And the exposure network on the ship is already fracturing in multiple directions at this point.
It's spreading.
It becomes a multi-continent puzzle within a matter of days. I mean, you look at case 3, this is another passenger who develops severe pneumonia on April 24.
Wow.
He has to be medevaced all the way from Ascension Island, which is an incredibly remote volcanic island, into another Johannesburg intensive care unit.
And then there's case 4.
Yes.
Yeah.
Case 4, an adult female, develops a fever on April 28. Her condition deteriorates into pneumonia, and she actually dies on board the ship on May 2.
The psychological toll on that ship must have been unimaginable for the passengers. I mean, people are falling ill, 2 people are dead on the ship, and the medical staff themselves are suddenly vulnerable.
Very vulnerable.
because the ship's doctor becomes case 5, coming down with a fever and severe muscle pain on April 30th, and then a ship guide, case 6, starts showing symptoms on April 27th.
Yeah, both of these individuals who are actively trying to manage the crisis eventually have to be medically evacuated to the Netherlands.
Just a nightmare scenario.
The involvement of the medical staff really underscores the extreme occupational hazard of the Andes strain. They were likely operating under standard droplet precautions early on.
Like regular masks and gloves.
Right. Which clearly were not sufficient to prevent transmission in those close-quarters clinical encounters. But honestly, the case that truly illustrates the vulnerability of our modern globalized world is case 7.
Yes. This is the one that really caught my attention in the source material. This is a male passenger who disembarks the MV Hondius back at St. Helena on April 22, and he decides to fly home to Switzerland.
Right.
But to get from St. Helena to Switzerland, he flies through South Africa, then connects through the massive international transit hub in Qatar, before finally landing in Switzerland on April 28th.
It's a huge journey.
He has this virus incubating in his system the entire time, and he doesn't develop a fever until May 1st.
The implications of case 7 are staggering when you think about contact tracing. We are talking about modern international travel here.
Right.
A person incubating a highly lethal hemorrhagic fever virus is sitting in multiple pressurized airplane cabins, sharing air with hundreds of people. He's walking through crowded duty-free concourses in Doha. He's using public restrooms, interacting with customs agents.
Just everywhere.
If he had become highly symptomatic and started shedding the virus while mid-flight or while delayed in a crowded terminal, the exposure web would have expanded exponentially.
Thankfully, he did the absolute right thing. I mean, as soon as the fever hit him on May 1st, he self-isolated, sought medical care, and tested positive on May 5.
He handled it perfectly.
But the sheer logistical nightmare of trying to track down everyone he might have been close to over a 10-day intercontinental journey, it's just overwhelming.
Nearly impossible.
And then there's case 8, who got off the ship way back on April 14th at Tristan da Cunha, didn't start feeling sick until April 28th and went into isolation there.
The geographic spread is just massive.
So you have one exposure to rodent droppings in Argentina that has now spawned a crisis spanning the South Atlantic, South Africa, Switzerland, and the Netherlands. How does the international community actually coordinate an intervention when a threat is moving that fast and the epicenter is a moving vessel?
It requires activating massive, multinational, bureaucratic, and logistical frameworks. I mean, by May 3, the situation on the ship is officially recognized as an acute, unmanageable crisis.
They need help.
Yes. The vessel is moored off Cape Verde, but the local health authorities make a crucial and very difficult assessment. Their facilities simply cannot handle a medical evacuation of this complexity safely.
It's too risky for them.
Exactly. They do not have the specialized biocontainment units required to transport these patients without risking their own healthcare workers. So the ship is rerouted north. They set course for the Canary Islands in Spain, specifically the port of Granadilla in Tenerife, arriving on May 10th.
So Tenerife becomes the central operational hub for this entire global response.
Yes, and the coordination is spearheaded by the European Union's Civil Protection Mechanism. This isn't just about, like, calling a few ambulances.
Right.
You have specialized evacuation flights being co-funded and organized by France, the Netherlands, Greece, and Ireland. They're deploying aircraft equipped with high-level isolation pods, which are essentially negative pressure chambers built right into the fuselage, to physically repatriate the infected passengers and exposed crew back to specialized containment hospitals in their whole countries.
That is an incredible logistical feat. And it wasn't just physical isolation they were relying on, right? There was a specific pharmaceutical intervention deployed here, an antiviral drug.
Yes, the European Commission facilitated the emergency deployment of an experimental antiviral called favipiravir.
Favipiravir.
The European Medicines Agency, acting incredibly swiftly, identified this drug as a potential therapeutic under compassionate use protocols.
What exactly is favipiravir? Like, how does it fight this kind of virus?
Favipiravir is fundamentally an RNA polymerase inhibitor.
Okay, let's unpack that.
Sure. So when an RNA virus, like hantavirus, enters a human cell, it uses an enzyme called RNA polymerase to copy its genetic material and multiply.
Got it. It's the copy machine.
Exactly. Favipiravir disguises itself as one of the building blocks the virus needs. When the virus tries to use it, the drug essentially jams the copying machinery.
Oh, that's clever.
It causes massive errors in the viral genetic code until the virus can no longer replicate, and it just dies off.
Wow.
The drug was actually donated by Fujifilm Pharmaceuticals in Japan and rapidly dispatched to the hospitals in France, Spain, and the Netherlands treating these patients.
The logistics of just getting that drug across borders under emergency use authorizations is a feat in itself.
There really is.
So, after the medevacs, after the experimental antivirals are distributed, what happens to the ship itself?
The MV Hondius eventually arrives in Rotterdam on May 18. The remaining 23 crew members are immediately placed into strict quarantine facilities.
And the boat.
The vessel itself undergoes a comprehensive top-to-bottom biodecontamination process. Every single cabin, the ventilation systems, the common areas, all of it is scrubbed and disinfected.
Man.
And the body of Case 4, who had died on board weeks prior, is safely removed under strict protocols for cremation.
Which brings us to the ultimate outcome of this mid-2026 report. Where does the specific outbreak stand now?
It is officially classified as fully contained.
That's a huge relief.
It is. The individuals who were exposed but asymptomatic, including their repatriated passengers and the crew in Rotterdam, they all completed a mandatory 6-week quarantine period.
Okay, see, that seems like an exceptionally long time to be locked in a room just to be safe. Like, why exactly 6 weeks?
Well, the duration is dictated by the biology of the virus itself.
Okay.
The maximum known incubation period, which is the absolute longest recorded time between someone being exposed to the Andes hantavirus and showing their first symptom, is 42 days.
42 days.
Yeah. Public health protocols cannot deal in averages when the stakes are this high. You have to wait out the absolute longest possible timeline that the virus could be hiding, silently replicating in someone's system, before you can definitively declare them clear.
That makes perfect sense.
And the rigorous enforcement of that 42-day window worked. There has been no evidence of secondary or tertiary community transmission anywhere in the world from this cohort.
As terrifying as the narrative of the MV Hondius is, it's actually a monumental success story.
It really is.
When systematic quarantine, standardized biocontainment medevacs, and international cooperation are fully funded and executed, the system holds.
It held beautifully, and the scientific community is actively capitalizing on that success. 21 different countries have now signed on to a coordinated research program.
Oh, that's great.
They're utilizing the clinical data and the immunological profiles gathered from this specific exposed cohort on the ship. They're basically turning this isolated crisis into a data engine to accelerate the development of candidate vaccines and targeted therapeutics for future hantavirus spillovers.
Okay, so we just walked through how humanity locks down a closed environment. I mean, a cruise ship is basically a steel box floating on the ocean. You know exactly who is inside. You can track their movements. You wait out the 42 days, and you scrub the metal surfaces.
A control variable, yeah.
Exactly. But the architecture of global biosecurity gets infinitely more complicated when the environment isn't a boat.
Much more complicated.
What do you do when the environment is like a dense tropical forest, an agricultural farm, or a bustling commercial warehouse?
That is the perfect contrast, and it brings us right to the second pathogen profile in the report, the Nipah virus.
Right.
Containing a virus in an open, completely interconnected ecosystem requires a drastically different approach than managing a ship's manifest.
So let's establish the baseline threat of the Nipah virus, because this is a pathogen that genuinely keeps virologists awake at night.
The Nipah is a highly lethal member of the Henipavirus genus.
Okay.
And to put that in context, the Henipavirus genus belongs to the larger Paramyxoviridae family, which also includes things like measles and mumps.
Oh, okay, so very common stuff.
Common, yes, but unlike measles, Nipah and its close relative Hendra are incredibly deadly zoonotic pathogens. We are talking about a historical case fatality rate that fluctuates between 40% and 75%.
That's insane.
Yeah. If you contract Nipah virus, depending on the strain of the local medical infrastructure, your statistical chances of survival are hovering around a coin flip.
It's a coin flip. Wow. Where does it even come from?
The natural reservoir, the host where the virus lives silently in the wild, consists of fruit bats of the genus Pteropus, which are commonly referred to as flying foxes.
Okay.
And these bats are widely distributed across vast swaths of Asia and Oceania.
So the virus lives in the bat. The bat doesn't get sick from it. But how does it jump the species barrier to a human?
The pathways are varied. Direct physical contact with an infected bat's bodily fluids is one. But more commonly, it involves the consumption of food sources that bats have contaminated with their saliva or urine.
Oh, gross. But okay, that makes sense.
And much like the Andes virus we just discussed, Nipah has demonstrated the ability to transmit directly from human to human, usually in healthcare settings where family members or nurses are exposed to the respiratory secretions of a critically ill patient.
Right.
But what the epidemiological data from South Asia reveals in this report is a fascinating yet really dangerous seasonal divide in how these spillovers actually occur.
Yeah, the report lays out this tale of two entirely different spillover mechanisms. We have a winter pattern and a summer pattern. The
Yes,
winter pattern seems deeply tied to agriculture.
it is. The winter pattern is heavily concentrated in Bangladesh and the neighboring Indian state of West Bengal. It aligns perfectly with the winter harvesting season for raw date palm sap, which typically runs from December through April.
Which we actually saw play out in early 2026.
We did, with two distinct outbreaks that have since been resolved. In January 2026, in West Bengal, two healthcare workers, a female and a male nurse in a town called Burasat, contracted the virus.
Working in a hospital.
Yes. They developed severe acute respiratory infection and neurological symptoms.
Jeez.
They were hospitalized, and the National Institute of Virology in Pune confirmed it was Nipah.
Okay.
Local authorities immediately initiated contact tracing, identifying 190 close contacts, and miraculously all 190 of those contacts tested negative, and the male nurse actually recovered by February.
That's incredibly lucky. Then you had the event in Bangladesh shortly after, in February.
Right, a fatal case in the Rajshahi division. A patient there consumed raw date palm sap on multiple occasions, developed severe neurological symptoms by late January, and passed away a week later.
And the contacts.
They traced 35 contacts in that instance, all of whom tested negative.
The mechanics of the date palm sap transmission are so specific. You have these agricultural workers hanging clay pots high in the trees overnight to collect the sweet sap.
Right.
And the flying foxes, which are naturally drawn to the shots, they fly in, they perch on the pots, and they drink the sap. And while they're drinking, they shed saliva, or they urinate directly into the collection pot.
Exactly.
Then a human comes along the next morning, harvests that raw, unpasteurized sap, and drinks it. It's essentially a textbook foodborne transmission route.
It really is.
You ingest contaminated food, the virus enters your gastrointestinal tract, and you get infected. It's a straightforward mechanical pathway, which means the public health messaging can be equally straightforward. Do not drink raw, unpasteurized date palm sap.
That is the exact public health intervention utilized in those regions.
Mm.
Boil the sap, or use protective skirts over the collection pots to keep the bats away.
Makes sense.
But then the report shifts to the summer pattern in the southern Indian state of Kerala. And suddenly, all those straightforward rules about foodborne transmission are totally thrown out the window.
This is where the report genuinely stunned me. Because in June 2026, we see an active cluster emerge in Kozhikode, Kerala. And the index case in this cluster didn't follow any of those expected behaviors.
None of them. The index case is a 43-year-old businessman from a municipality called Ramanattukara. On June 6, he develops a persistent fever and a severe headache.
Okay.
Within 4 days, his condition just crashes. By June 10th, he is admitted to the Government Medical College Hospital and placed on mechanical ventilation. His samples test positive for Nipah virus.
Wow.
But when the epidemiological teams start reconstructing his previous weeks, they find he didn't consume any date palm sap or exotic fruits. He wasn't bitten or scratched by a bat. He had no contact with any sick individuals.
See, if there is no contaminated food, no physical bite, and no sick humans around him, how does a businessman contract a virus that puts him on life support in a matter of days?
The investigation team zeroed in on a specific property. He had recently rented an old commercial go-down.
Which is like a large warehouse space, right?
Yes, exactly. And he had gone inside to clean it out himself. When the health inspectors examined the structure, they found it was heavily infested. The rafters contained a large, active population of fruit bats, and the floor was covered in significant accumulations of dried bat droppings, urine, and secretions.
Oh no. So it wasn't ingestion, it was inhalation.
The leading epidemiological consensus points directly to aerosolized environmental exposure. Think about the physics of cleaning a dusty, enclosed space.
All right, you're sweeping.
As he was sweeping the floors, moving old boxes, and disturbing the environment, he was mechanically aerosolizing years of dried bat guano. Those viral particles preserved in the dried secretions became airborne dust. He inhaled that contaminated dust deep into his respiratory tract.
That is a fundamentally different type of terror compared to food poisoning. I mean, you can choose not to drink raw sap. You can't choose not to breathe while you are sweeping out a commercial
Oh,
warehouse.
exactly.
How does a local government even respond to a threat that is literally suspended in the air of a building?
The response requires intense, hyper-localized containment and surveillance. The Kerala Health Department, operating under Health Minister K. Muralidharan, launched a massive protocol. They immediately built a comprehensive contact registry of 77 primary contacts connected to this businessman.
Who makes up that list of 77 people? It can't just be his family.
No, the majority of them are healthcare workers, 58 in total.
58 healthcare workers. Wow.
This highlights how vulnerable medical staff are when a patient presents with an undiagnosed severe respiratory illness. The rest of the list comprises 14 family members and 5 close friends. The health department then rigorously stratifies the risk level of each contact. 13 of those individuals were classified as high risk due to their proximity to the patient's bodily fluids. They took the 2 individuals at the absolute highest risk tier and placed them into strict institutional quarantine facilities to monitor for any sign of a fever.
Beyond just isolating the contacts, they're also trying to manage the physical environment around Ramanattukara, right?
They established physical containment zones. Residents within those zones are under strict advisories to practice social distancing and wear masks in public spaces.
Okay.
But crucially, the messaging also targets the environmental overlap. Residents are warned to avoid touching, harassing, or provoking any fruit bats, particularly during this high-risk window between May and September when bat populations are highly active and actively shedding virus.
This incident in Kerala seems to be fueling a major scientific debate in the background of this report, too.
It is. It's driving a critical conversation about the structural evolution of zoonotic spillovers. There is an ongoing debate featured in the Indian Journal of Medical Research.
What are they debating?
Well, if you look at past Nipah outbreaks, like the massive one in Malaysia back in 1999, the bats infected pigs, and the pigs acted as an amplifying intermediate host before infecting humans.
Right.
In Bangladesh, we have the date palm sap as the clear vehicle. But in Kerala, extensive field surveys consistently find Nipah antibodies in the local bat populations, yet there is zero evidence of an intermediate animal host and no evidence of a contaminated food vehicle.
So the virus is cutting out the middleman entirely?
Exactly the concern. The environmental overlap itself is becoming the primary vector, as rapid urbanization and human commercial activity push deeper into traditional wildlife habitats, or, conversely, as wildlife adapts to using man-made structures like abandoned warehouses for roosting, the pathways of infection are changing.
It's adapting to us.
We have to expand our biosecurity framework. We can't just regulate agricultural products anymore. We have to consider the air quality and the ecological management of shared enclosed spaces where humans and wildlife intersect.
The contact tracing in Kerala, like tracking down those 77 people, monitoring every symptom, is a colossal effort designed to stomp out a spark before it becomes a fire.
Yes.
But what happens when that spark already burned across the globe? What happens when a virus mutates so efficiently that contact tracing becomes completely futile, and public health has to pivot from putting out fires to permanently managing the embers?
You are describing the monumental transition of COVID-19 from a pandemic crisis into an endemic baseline.
Let's look at the global statistics for SARS-CoV-2 from May 2026, because these numbers paint a picture of a pathogen that has deeply integrated itself into the background noise of human existence.
It has. The shift to endemicity is one of the most complex governance challenges in modern public health. If we examine the hard data collected during the week of May 11 to 17 in 2026, sentinel virological surveillance networks across 69 reporting countries processed just over 60,000 samples.
Okay.
Out of those, they returned only 701 positive results.
So we are looking at a global test positivity rate of roughly 1.2%.
Correct. When you span that to a full 28-day cycle from mid-April to mid-May, the total reported global cases hovered around 11,560.
That's pretty low.
It actually represents a decrease from the prior 4-week cycle. And the mortality figures are equally telling. 383 global deaths during that period, with approximately 88% of those fatalities occurring in individuals aged 65 and older.
Those numbers represent a highly managed threat. If we zoom in specifically on the United States, how does the landscape look?
In the U.S., the critical metric to watch is the effective reproduction number, often referred to as the RIPE. This number represents the average number of people that one infected person will pass the virus to. If the ART is above 1.0, the outbreak is growing. If it is below 1.0, the outbreak is shrinking.
Got it.
In May 2026, the U.S. ART is hovering right around 0.98. That means the transmission chain is slightly decaying or holding stable across 48 states. To put the clinical burden in perspective, COVID-19 diagnoses currently account for a minuscule 0.1% of all emergency department visits nationwide.
It's basically fading into the background, clinically speaking. But biologically, the virus is anything but static. The report details what I can only describe as a genomic weather forecast. The virus is constantly mutating.
The viral landscape is exclusively dominated by the evolution of Omicron sublineages. What we are witnessing is a fascinating evolutionary trade-off.
How so?
Well, the virus is under constant pressure from global population immunity, whether from previous infections or vaccinations. To survive, it has to mutate its spike protein, which is the part of the virus that attaches to our cells, just enough to evade our immune defenses. But in doing so, it has largely traded away its clinical severity. It has evolved to infect the upper respiratory tract incredibly efficiently, but it is less effective at causing the deep, severe lung damage we saw early in the pandemic.
It's an evolutionary strategy. I mean, the virus doesn't gain an advantage by putting its host in an intensive care unit. It gains an advantage by keeping the host walking around, coughing, and spreading the next variant.
Exactly.
What specific variants are the surveillance networks tracking right now?
Global molecular surveillance is tracking a complex family tree of lineages. For instance, there is XFG, currently classified as a variant under monitoring.
XFG, okay.
It accounts for about 31% of the sequence samples globally, but its prevalence is actually dropping. It was at 40% a month prior.
Yeah.
It remains stable in the Americas, but is losing ground in Europe and the Western Pacific.
Then you have other branches of the family tree, like NB.1, .8.1.
Which sits at about 25% global prevalence. Its trajectory is reversed. It is stable globally, but actively increasing its footprint in the Western Pacific while declining in the Americas. You also have BA.3.2 at 20%, which is currently pushing upward in both the Americas and Europe. And older variants like JN.1 have faded into a residual baseline.
The level of genomic tracking is incredible. It really is like a weather forecast. We aren't tracking BA.3.2 because we expect some catastrophic societal shutdown. We track these microscopic shifts in the viral sequence so we know if we need to update the composition of the booster shots for nursing homes this fall. It's routine, calculated forecasting.
It is the ultimate routinization of a threat. But while the biological virus is contained within these endemic parameters, the geopolitical shockwaves it generated are still actively reshaping international diplomacy.
Which brings us to the diplomacy side of disease. The report highlights the intense negotiations surrounding the International Pandemic Agreement happening in July 2026.
The diplomatic effort is massive. You have the Director General of the World Health Organization, Tedros Adhanom Ghebreyesus, alongside leaders like Brazilian President Luiz Inácio Lula da Silva, spearheading a joint appeal. They are aggressively urging the international community to finalize this pandemic agreement. The negotiations are highly complex, but they basically revolve around three foundational pillars.
Let's walk through those. What is the first pillar holding up this agreement?
The first pillar addresses the political reality of sovereignty. Throughout the pandemic, there was immense public anxiety regarding international overreach.
Right.
The agreement explicitly codifies that the WHO remains a coordinating and advisory body. It explicitly states that the agreement does not grant the WHO any legal authority to mandate domestic lockdowns, dictate border closures, or enforce vaccination requirements within any sovereign nation.
So it's drawing a hard legal line to ensure countries don't feel they are signing away their domestic authority just to participate in global health tracking.
It is a pragmatic necessity to build international consensus.
Makes sense.
The second pillar is arguably the most transformative: equity. Specifically, the negotiators are trying to implement a framework called the Pathogen Access and Benefit Sharing System, or PABS.
Okay, the PABS system addresses a historical injustice in how we share medical data, right? How does the current system fail?
Historically, global health has operated on a transactional, crisis-driven model. If a novel pathogen emerges in a developing nation, the global expectation is that the country will immediately sequence the virus and share that genetic data with the international community.
So everyone can study it.
Right. But what often happens is that pharmaceutical companies in wealthier nations utilize that free data to develop highly lucrative vaccines and therapeutics.
Oh, I see.
When the final product is ready, the country that originally provided the data and is likely suffering the brunt of the outbreak cannot afford to buy the countermeasures or is pushed to the back of the line.
So they supply the blueprint for free but get locked out of the hardware store. How does PABS fix that?
ProBS attempts to replace that transactional model with a permanent, legally binding network. The core principle is that rapid, transparent sharing of pathogen genetic sequence data must be explicitly decoupled from market forces and inextricably linked to equitable access. If you share the data, you are guaranteed a proportional share of the resulting medical countermeasures, vaccines, and diagnostic tools, regardless of your nation's purchasing power.
That is a massive paradigm shift. But negotiating international treaties usually takes decades. Why is there such an aggressive push to finalize this specific one in July 2026?
That urgency is the third pillar. The negotiators are being driven by sobering statistical models produced by leading epidemiological teams.
What do the models say?
These models estimate that there is a 25% probability of another major pandemic one with the potential to severely disrupt global society occurring within the next 10 years.
A 1 in 4 chance in the next decade. Those are terrifying odds. What is driving that risk profile?
It's a combination of the shifting environmental factors we discussed regarding NEPA deforestation, urbanization, and the expanding interface between humans and zoonotic reservoirs, combined with the underlying ever-present risks of laboratory biosecurity breaches.
It's a lot of pressure.
The overarching structural imperative here is stark. The global community cannot afford to rely on reactive, outbreak-driven funding models anymore. Passing the hat for donations after a virus has already crossed borders is a recipe for failure. We must build proactive financing mechanisms and equitable distribution frameworks into international law before the next spillover event occurs.
The reality of that 25% statistic is haunting, but the tragic truth of global health is that a potential future crisis for the developed world is an active, ongoing catastrophe for someone else right now.
That's unfortunately very true.
For the Democratic Republic of the Congo and Uganda, the worst-case scenario isn't a statistical probability for the next decade. It is happening today.
We're moving from the heavily managed tracking of COVID-19 to a perfect storm of vulnerability. The Bundibugyo Ebola epidemic, currently raging in the DRC, represents a failure at multiple levels of the biosecurity architecture.
Reading this section of the report is deeply sobering. Let's walk through the inception of this outbreak in May 2026. This isn't a new threat for the region, is it?
It is the 17th recorded outbreak of Ebola virus disease in the Democratic Republic of the Congo.
17th. Wow.
The sheer frequency is exhausting for the local health systems. This current crisis emerged just 5 months after the country had finally declared the end of a previous outbreak in the Kasai province in December 2025.
It just doesn't stop.
But what makes this May 2026 event so devastating is the epidemiological timeline. It reveals a prolonged period of silent, undetected community transmission.
How does an incredibly violent hemorrhagic fever spread silently? Where did it even start?
The retrospective investigation points back to late March 2026. Red Cross workers who were involved in dead body management, safely handling and burying the deceased, contracted the virus in a mining area called Mongwalu.
Okay.
Because the initial symptoms of Ebola fever, fatigue, muscle pain mimic so many other endemic diseases like malaria or typhoid, it went completely undetected.
It blended in.
Yes, the virus began to move. By April 24, a health worker in Bunia presented with severe symptoms, including hemorrhaging and vomiting. Throughout late April and early May, intra-household transmission was silently tearing through families across Ituri province.
The official public health alarms weren't pulled until mid-May, which means the virus had nearly a 2-month head start.
Exactly. The official declarations came on May 15th. The DRC Ministry of Public Health finally declared an outbreak after the National Institute of Biomedical Research in Kinshasa definitively confirmed the presence of the virus in clinical samples.
And it crossed borders, too.
On the very same day, Uganda declared its own outbreak. An elderly man had traveled across the border from Ituri province, seeking better medical care in Kampala, and died there. Recognizing the rapid cross-border spread, the WHO elevated the crisis to a public health emergency of international concern, or PHEIC, on May 17.
A PHEIC is the highest level of alarm under international health regulations. And looking at the numbers from mid-June, it is easy to see why. The escalation is just staggering.
The raw data is grim. As of the report, the cumulative case count stands at 992. That includes 827 laboratory-confirmed cases and 165 probable or suspected cases.
Nearly 1,000 people.
The documented death toll is 194. That generates an aggregate case fatality rate of approximately 23.5%.
God.
The geography of the outbreak has expanded rapidly, moving outward from Ituri province to infect populations in North Kivu, South Kivu, and establishing those imported transmission chains in Kampala.
But the critical question here is why? Why did it go undetected for 2 months? I mean, the DRC has fought Ebola 16 times before this. They know what it looks like. They have laboratories.
They do.
This reveals what you termed the double vulnerability, a catastrophic failure in both our diagnostic technology and our medical therapeutics.
Let's unpack the diagnostic failure first.
Sure.
How did the labs in Bunia miss this in March?
It is a tragedy of molecular specificity. Ebola is not just one uniform virus. It is a genus that contains several distinct species.
Okay, I didn't realize that. Yeah, the most historically common species, and the one responsible for the massive West African epidemic and the majority of recent DRC outbreaks, is the Zaire Ebola virus. Because Zaire is the most common, the vast majority of our diagnostic tools are calibrated specifically for it.
Oh, no.
This current outbreak, however, is being driven by the Bundibugyo Ebola virus, or BDBV.
And the standard testing machines couldn't tell the difference?
To understand the failure, you have to look at how the tests actually work. The Provincial Public Health Laboratory in Bunia was utilizing standard Ebola expert assays. These are rapid PCR tests.
Right, PCR tests.
The PCR test works by using specific chemical primers that are designed to physically lash onto a highly specific known sequence of viral genetic code. If the primers find the sequence, they amplify it, and the machine reads a positive result.
Okay.
The assays in Bunia were optimized with primers, searching exclusively for the genetic signature of the Zaire strain.
I see where this is going.
When they loaded the early blood samples from the Bundibugyo patients into the machines, the primers couldn't find the Zaire sequence. The tests returned false negatives. The machine essentially reported that there was no Ebola present, when in fact, a slightly genetically different strain was overwhelming the patient's system.
It's like having a state-of-the-art home security system, but the cameras are explicitly programmed by the manufacturer to only recognize burglars wearing red shirts.
Exactly.
A burglar breaks in wearing a blue shirt, the Bundibugyo strain, and he walks right past the cameras. The alarm literally doesn't go off. The doors stay open, and the virus just keeps walking through the community.
That analogy perfectly captures the systemic blind spot. The alarm did not go off. Healthcare workers assumed they were dealing with malaria or severe bacterial infections. They didn't implement the rigorous isolation protocols required for Ebola, and the virus used that window to establish deep, complex transmission networks.
That's devastating.
And once the laboratories finally recalibrated and spotted the blue shirt burglar, the second vulnerability became agonizingly apparent: the therapeutic deficit.
Right, because once you finally diagnose a patient with the Bundibugyo strain, what tools does a doctor have to save their life?
The devastating answer is almost none.
Really?
None. There are currently no internationally approved vaccines, highly effective therapeutics, or rapid point-of-care diagnostics specifically tailored for the Bundibugyo strain.
What about the vaccines we've heard about?
The incredible medical breakthroughs we celebrated in recent years, like the highly effective Ervebo vaccine or the two-dose Zabdinum Avabe regimen, those were developed and licensed strictly to neutralize the Zaire strain.
So a vaccine for the Zaire strain offers absolutely no protection against Bundibugyo.
The vaccines generate antibodies designed to target the specific shape of the Zaire spike glycoprotein. The Bundibugyo glycoprotein is shaped differently. Studies conducted in non-human primates indicate that the Zaire vaccines offer incredibly low, practically negligible cross-protection against Bundibugyo.
That is heartbreaking.
You cannot vaccinate your way out of this specific outbreak with the stockpiles currently sitting in Geneva.
Is the scientific community working on a solution to this? We can't just be completely defenseless against an entire branch of the virus family.
There is promising research underway. Institutions like the University of Oxford, in partnership with Moderna, are actively developing a multivalent filovirus vaccine.
Multivalent, what does that mean exactly?
Multivalent means the vaccine contains the genetic instructions to teach the immune system to recognize multiple targets simultaneously. In this case, the Zaire, Sudan, Marburg, and Bundibugyo glycoproteins all in one single shot.
Oh, that would be amazing.
But that technology remains in early preclinical trials. It is years away from regulatory approval. It offers no immediate help to a doctor standing in an isolation ward in Ituri province today.
And the reality of standing in an isolation ward in Ituri province is a nightmare all on its own. Fighting a highly transmissible hemorrhagic fever requires stable infrastructure, clean water, community trust, and absolute security. And Ituri province right now has none of those things. It is an active humanitarian catastrophe.
The epidemiological complexities are colliding with immense geopolitical instability here. This outbreak is expanding aggressively within a highly complex conflict zone. You have dozens of active armed rebel groups, widespread illicit mining operations driving rapid population movement, and profound societal displacement.
It's just chaos.
Current estimates indicate there are over 900,000 internally displaced persons, or IDPs, residing within Ituri province alone.
900,000 people who have fled violence, living in makeshift camps, lacking basic sanitation, crowded into tents.
Exactly. Those are the precise environmental conditions that accelerate viral transmission exponentially.
Yeah.
If someone falls ill in an IDP camp, isolating them and safely managing their bodily fluids is nearly impossible.
And the medical teams are in danger too, right?
Furthermore, the public health response team deployed by the government and the WHO are facing severe, life-threatening security challenges. The report documents multiple instances of armed attacks on medical staff and burial teams who are simply trying to safely inter the highly infectious remains of victims. The virus thrives in the chaos of conflict.
Faced with a pathogen that has a 23% fatality rate, no vaccine, and is spreading in a war zone, how does the international community even begin to throw a net over this?
It requires an overwhelming mobilization of financial and operational resources. On June 5, the Africa Centers for Disease Control and Prevention, in coordination with the WHO, launched a massive joint response plan.
What are they asking for?
They're seeking $518 million to flood the zone with supportive care infrastructure, mobile testing labs, and security logistics. The United States government immediately mobilized an additional $38 million in direct funding, elevating their total bilateral commitment to the region to over $200 million.
It's a massive investment.
The U.S. CDC has also issued Level 3 travel notices, advising against all non-central travel to the DRC.
But the fear isn't just contained to Central Africa. In a highly connected world, a fire in one room threatens the whole house. The report details how this outbreak in the Congo is triggering biosecurity alerts an ocean away in South America.
It is a profound illustration of global interconnectivity. The health ministries in Colombia, Chile, and Brazil are operating on extremely high alert right now.
Why South America specifically?
Well, Brazil recently had to activate its national biosecurity protocols to isolate and test 2 suspected cases. Thankfully, those tests returned negative. But the anxiety in South America is incredibly high right now because they are in the final preparations for the 2026 FIFA World Cup matches.
A massive global gathering event drawing millions of international travelers into crowded stadiums, happening simultaneously with an uncontained Ebola outbreak.
The logistical nightmare is obvious. A single traveler unknowingly incubating the Bundibugyo virus, boarding a flight from an African transit hub and landing in Rio de Janeiro, could theoretically introduce a highly lethal pathogen into a densely packed multinational crowd.
Oh, wow.
The regional epidemic in the DRC is an immediate, tangible threat to the safety of international events globally.
So when we look at the immense tragedy and the mechanical failures of this Bundibugyo outbreak, what is the overarching structural imperative here? What does the global health apparatus need to learn from this disaster?
The imperative is an absolute necessity to transition our scientific and funding approach. We can no longer afford to play molecular whack-a-mole, waiting for a specific viral strain to emerge, and then spending a decade developing a bespoke vaccine for it while ignoring its lethal cousins.
Right.
Developing a vaccine exclusively for the Zaire strain while leaving populations completely vulnerable to Bundibugyo or Sudan strains is a strategic failure. The international community must prioritize and heavily fund the development of broad-spectrum, multivalent medical countermeasure platforms that target entire viral families simultaneously.
We need diagnostic machines and vaccines that recognize the burglar regardless of what color shirt he decides to wear on any given day. It is incredible to step back and look at the entirety of this viral outbreaks containment status report that you, the listener, brought to our attention. We have covered a massive amount of ground today.
A huge amount.
We started with an outbreak contained within the steel walls of a ship in the South Atlantic. We moved to a dusty commercial warehouse in southern India, analyzed the global statistical tracking of an endemic respiratory virus, and ended in the chaotic epicenter of a hemorrhagic fever outbreak in a Central African conflict zone.
When you synthesize all of those disparate narratives, a profound dichotomy emerges that defines the reality of global biosecurity in 2026.
What's the dichotomy?
On one hand, human ingenuity and scientific capability are genuinely astounding. We have the logistical capacity and the specialized medical technology to intercept a highly lethal hantavirus on a moving cruise ship and safely extract the patients.
That part was amazing.
We have the forensic epidemiological skill to trace an invisible airborne Nipah virus infection back to a single individual disturbing dried guano in an abandoned building.
It is miraculous. But on the other hand, the report exposes how incredibly vulnerable we remain to our own systemic blind spots.
Yes.
We have diagnostic machines that miss a deadly Ebola outbreak for 2 months simply because the genetic sequence shifted slightly. We have brilliant medical interventions that are rendered utterly useless on the ground because of systemic funding failures, bureaucratic delays, and geopolitical conflicts that make delivering a vaccine impossible.
It is a deeply humbling paradox. We are simultaneously more protected and more exposed than at any point in human history.
And the reason this matters so deeply to you, listening right now, whether you are commuting to work or sitting in your living room, is because we are all inextricably woven into this exact same interconnected web.
You can't escape it.
You cannot separate these events from your own life. A fruit bat seeking shelter in a go-down in Kerala, a mouse leaving droppings in a rural shed in Argentina, a diagnostic machine returning a false negative in a Bunia laboratory. These highly localized events directly impact the viability of a global supply chain, the safety of a World Cup match in Brazil, or the health protocols on your next international flight.
Absolutely.
Your personal safety is intimately tied to the ecological balance of a forest half a world away, and to the funding of a laboratory you will never see.
Which leaves us with a final and perhaps highly provocative thought to consider as we close out this deep dive into the source material.
Let's hear it.
If you look closely at the inception points of the most dangerous threats we discuss, the Andes hantavirus, the Nipah outbreak, the origins of the Ebola epidemic, none of them began as human-to-human transmission events.
That's true.
They all originated from moments of environmental overlap. They were triggered by humans pushing deeper into wildlife spaces for agriculture or mining, or by wildlife adapting to human structures as their natural habitats were destroyed.
So the initial collision wasn't between two people, it was a collision between humanity and nature.
Precisely. Yet, when you look at our immense global health infrastructure, it is overwhelmingly, almost exclusively, designed to react to human sickness.
Right, the hospitals, the ICUs.
We pour our resources into building better ventilators, faster PCR tests, and mRNA vaccines, waiting until the patient is already in the hospital isolation ward to start fighting the pathogen.
We're reacting.
But considering the trajectory we are on, and that looming 25% probability of another major pandemic driven by zoonotic spillover, perhaps the entire philosophy of global health needs to shift.
How so?
Perhaps the future of protecting human life needs to be slightly less focused on human medicine and significantly more focused on proactive ecological management.
That is a staggering reframing of the problem.
If the next catastrophic threat is statistically guaranteed to emerge from a disturbed natural habitat, then maybe the ultimate, most effective vaccine isn't a targeted shot in the arm administered in a clinic.
What is it then?
Maybe the ultimate vaccine is a fundamental structural change in how human civilization interacts with the wild.
The ultimate vaccine is a change in how we interact with the wild, because until we address the root cause of these environmental overlaps, we are always going to be playing catch-up.
We will.
We will always be swimming in those diagnostic muddy waters, desperately waiting for the test results to tell us what is already broken. It is an incredible thought to carry with you.